When the cloud stumbles, lessons from the recent AWS outage. On October 20th, 2025, much of the internet trembled. A major Amazon Web Services AWS outage disrupted dozens of mainstream websites, apps, and services globally. From Snapchat and Fortnite to financial platforms like Robinhood and Coinbase, many users woke to a suddenly broken digital world. What caused this disruption? What made it so widespread? And what does it teach us about how we build, depend on, and protect our online systems? What happened? DNS, DynamoDB, and cloud centralization. AWS reported that the root issue involved DNS, domain name system, resolution failures, particularly in its US East 1 region, hurting access to its database service DynamoDB, among others. In short, DNS is the Internet's address book, translating user-friendly domain names, e.g. example.com, into IP addresses. If DNS fails or becomes unreachable, even if data is intact, services can't route requests correctly. Coupled with that, AWS internal database dependencies like DynamoDB exacerbated the failure for many services relying on it. The outage lasted roughly 3 hours, though recovery phases and backlogs stretched the disruption. Unlike a data breach or known cyberattack, experts noted this was likely a technical infrastructure fault, a reminder that even trusted cloud services are not immune to internal failure. The fallout, what it broke, and who felt it. Because many major web services and apps lease infrastructure from AWS, the ripple effect was massive. Social and messaging apps like Snapchat, Signal, gaming platforms including Fortnite, Roblox, finance tools like Robinhood, Coinbase, e-commerce and home tech, Amazon.com, Alexa, Prime Video. Even banks and telecom providers in the UK reported outages, e.g. Lloyds, BT, HMRC. What this showed starkly is how deeply integrated AWS is in the fabric of modern digital operations. Why it keeps happening: concentration plus complexity. This outage wasn't an isolated freak event. It underscores two structural vulnerabilities. Over-reliance on a few cloud giants, a handful of providers, AWS, Google Cloud, Microsoft Azure, dominate global cloud infrastructure. When one falters, many downstream systems suffer. Complex interdependencies. Modern systems layer services, databases, DNS, APIs, microservices, all depending on one another. A failure in DNS or core database can cascade downstream. Experts have warned for years that DDoS, cascading errors, or infrastructure misconfigurations could hit this kind of blow. See research into DDoS resilience, DNS vulnerabilities, cloud architecture risks. Lessons and what we must do next. Diversification is no longer optional. Companies should not put all their eggs in one AWS or any single provider, region, or service. Multi-cloud strategies spreading risk between AWS, Azure, GCP, and active failover mechanisms should be standard. Decentralize critical services. Some services, like DNS, should have redundancy across independent providers. Relying exclusively on one provider's infrastructure magnifies risk. Build observable, resilient architectures. Systems must be designed to degrade gracefully. Latency monitoring, circuit breakers, fallback caches, and traffic routing flexibility matter greatly. Transparent post-mortems matter. When incidents like this occur, full disclosure of root causes helps the industry learn and strengthens trust. AWS investigations will be closely watched. Regulation and oversight may intensify. Given how vital cloud infrastructure is for social, economic, and civic systems, regulators globally may push for more scrutiny, audits, and standards for cloud providers. The October 2025 AWS outage was a wake-up call. The internet often acts like magic, but behind it lie fragile systems, human engineers, and design trade-offs. As we rely more on AI, IoT, and digital life, building with resilience, not just performance, must become the new baseline. Let this outage not merely be a story to read, but a chance to architect a safer digital future.